My name is Rachita. I'm a vice president at Barclays, and I'm based out of Noida. I belong to the Quantitative Analytics team in Barclays. In terms of my experience, I've been in the credit risk analytics domain for more than a decade now, primarily working on the credit risk models. Here at Barclays, my responsibility is looking at and managing and developing credit risk models for key Barclays portfolio. So actually, it's a very massive switch from the earlier presentation where we looked at a lot of unsupervised data. This is all banking data. We look at banking data, which is pretty much way more structured as compared to what image data would look like. We deal in the world of numbers, balances, payments, and credit cards usage, and so on. Okay. So my topic is about Python for decision science and machine learning at Barclays. So we'll start the topic with a brief introduction about Barclays worldwide and also India in particular. We will then talk about what has been a Python migration journey so far, what is that we have already done and achieved. And the next section is about leveraging Python, what is our way forward, what is that we are aiming to achieve in the next 2 to 3 years to come. So let me just start with a quick trivia. So how many of you had heard about the name of Barclays and that Barclays is a bank? It looks quite promising, but I hope the hands were not raised after looking at our booth outside today. So it was before that. Okay. So for those who don't know about Barclays, Barclays is a consumer, corporate, and investment bank. We offer products and services across personal, corporate, and investment banking. We have a very strong presence in UK and US, offering personal and investment banking products across these markets. Barclays has a very long 325 years of history, and its expertise has primarily been in the domain of banking and financial services. We have close to around 80,000 employees worldwide, and we operate in almost 40 odd countries. In 2018, Barclays reported a net operating income of close to 18.74 billion. Slightly on a lighter note, for all the football lovers sitting in this room, Barclays is also the official sponsor of the English Premier League, one of the most reputed and popular football tournaments in the world. All the more reason to know about Barclays. Okay. So moving on. So Barclays has a history of close to around 325 years. It's truly a privilege to be a part of this organization. So we started in 1960 when James Firm and Thomas started trading in the Goldsmith Banker in the streets of London. And this was the time when India was ruled by Aurangzeb, the Mughal Emperor Aurangzeb. And we were very far behind in terms of setting up a formal financial sector in India. Since then, the company underwent a lot of changes. Our logos have changed several times over the last 325 years. In 1986 was a very important milestone for Barclays. It was registered as the first British bank in both the Tokyo and New York stock exchanges. In 2008, when the entire world was hit by the global recession, Barclays purchased Lehman Brothers' North American investment banking and capital market business. In 2018, Barclays transformed its organizational structure and created what is called the ring-fenced bank, dividing UK from rest of the portfolios. So several changes over the last 325 years, but truly a success story which has been built over this 300 odd years. Now moving on. Now some stats about India. Risk at Barclays has a very strong presence in India, cutting across all the key risk services. Over time, India has actually evolved into a data analytics ecosystem which is supported by very diverse talent. In India, we are present in Noida, Mumbai, Pune, and Chennai. We cater to almost all the key risk pillars, starting from credit risk, fraud risk, market risk, and operational risk. In summary, we actually play a very pivotal role in Barclays worldwide. So there are some new terms here like credit risk, fraud risk, market risk, and operational risk. I'll maybe briefly touch on each of these items. So credit risk is when we try to assess the credit worthiness of an application or a customer. Say suppose there's a new customer who comes to us and applies for a credit card or a loan. we try to gauge whether the customer is going to be profitable or not. So bringing him or her on board is going to bring us more profits than the loss will possibly incur. So that becomes under the umbrella of credit risk. Fraud risk, as the name indicates, how do we capture fraudsters, which can be a first party fraud or a third party fraud. Similarly, there's things like market risk, dependent on market conditions, changes to the macroeconomic scenarios, and so on. The last one is operational risk. Operational risk is gaining significance a lot lately thanks to the regulators in these countries. Again, operational risk is about breakdown of your data systems and so on. So things to do with the operational side of it. We in India cater to all the four risk services, starting from credit risk to operational risk. In summary, as I said, we play a very pivotal role in Barclays globally. Now moving on, a brief description about the team that I belong to. As I mentioned, I'm a part of the Quantitative Analytics team. So Quantitative Analytics team comprises of the following teams, and each team is responsible for a very key milestone in the entire model development cycle. So it starts with the model data and execution team, which is basically the first phase of any model development life cycle. The model development life cycle typically begins with data gathering and data cleansing. And this is where the model data and execution team plays a pivotal role. The next phase is model development. So we have the cleansed data, we have already gathered the data, and that is when we start developing models to be able to make judgmental decisions. And this is where the model development team plays a role. So once we have the models, the next obvious stage is to get these models implemented into our production systems such that the business can drive profitable decisions from it. And this is where the model implementation team comes into picture. The last phase is the model monitoring team, which basically assesses if a certain model is performing as expected or not. Just in case that there is a deterioration in the model performance, we quickly trigger to the first team, which is the model data and execution team, and the entire life cycle of the model begins again. So in terms of domains, we look at all the key domains like risk, finance, treasury, and lending. Now coming to some products, we look at retail products, which are typically products like say credit cards, loans, mortgages, personal loans, and so on. We also have a presence in the wholesale banking, corporate banking, and investment banking. Now coming to some important, interesting features like technologies. Until last year, which is 2018, SaaS was probably the most commonly used technology that we were using for all data-related activities within Barclays. Over the last 1.5 years, we've tried to migrate from SaaS and try to adopt freeware softwares like Python and R. We also work in Hadoop setups, and that is when we also leverage Spark, which basically talks about parallel computing and so on. And in terms of project management tools, we look at Jira, and with certain version control tools also, which is regularly used in our day-to-day activities like Bitbucket. Now coming to our stakeholders, our primary stakeholder is the model validation unit, which basically validates the models that is developed by the model development team. We also work very closely with the business heads of risk, finance, and treasury. So they are basically the chief credit risk officers for each of these individual pillars of individual domains. We also work very closely with the IT and the data management teams. Okay. So this brings us to the end of the first part of my talk, where I just wanted to give an introduction about Barclays and what do we do as an organization. The next part of the talk is actually our journey so far when it comes to embracing Python. Over the last few months, Barclays has been working towards a very fast adoption of Python as one of the primary technologies for doing all kinds of data-related activities. The first step in this journey is to identify the key challenges. And that's in fact probably the biggest and most important step in the entire journey. And I'm sure all of us would have faced this to some degree or the other when we started onto their migration journeys. So the first key challenge is develop talent. As I said, until 2018, SaaS was probably the most commonly used technologies. And hence, migrating to Python or R for that matter required extensive training within the teams. So under this strategy, we had multiple internal trainings conducted for for colleagues across the different geographies, both in India as well as across the globe. We had quite a few train the trainer sessions wherein we would choose a colleague, train him on Python, and then set him up to train the remaining teams. We also had a tie up with Coursera to provide sponsored trainings for selected few colleagues. So this was the first challenge, develop talent. Now moving on to the bigger challenge, which is develop infrastructure. So this is probably one of the bigger challenges, and solving that was absolutely not easy. And in fact, this is one of the steps which required heavy investment as well. But as it is said, Rome was not built in a day. Given the complexity that the bank has, so many products, so many domains, and such huge card user base, it was absolutely not possible to transfer all the data into some kind of a data or analytic platform that is Python compliant. We have started on to the journey, but I'm sure it's going to take us some while until we completely do it for all the portfolios within Barclays. So here, we are actually setting up Python-supported development and UAT environments across all the different groups. The end goal is to have every data or work stream migrated to a platform which is Python compliant. The second phase is, of course, we've built the data analytics environment. The next phase is to ensure that we can actually implement our models. Whatever analytical solutions that we are developing, we should be in a phase to be able to implement them, such that our business can quickly drive profitable decisions out of it. So the next phase is to basically enhance the production servers to support implementation of Python-based tools. As I said, Rome was not built in a day. We are on the journey. We have done that for some of the portfolios, but it still needs to be done for many of the other portfolios that Barclays has. Regarding the third point, which is also equally important and we should be very careful about, that is to ensure consistency. Now, given that Python is a freeware, ensuring consistency across different teams and individuals within Barclays was a challenge. So people could pick up any package from the internet and start coding it. But as an organization, we were not allowed to do that. And this is primarily because we belong to a financial domain where everything is extremely regulated, right from data to models is extremely regulated by regulators. So that is when having consistency in everything that you do was extremely critical. And how did we solve it? We created what is called as a standardized Python notebooks, which basically encompasses the end-to-end model development for a huge range of models. And the typical range of models could be, say, regression-based, where we look at linear or logistic regression, time series models, and even complex machine learning models. So what it ensured is that every individual who is working on Python uses the same set of codes, same set of packages, and there are no discrepancies in the usage of packages. This is going to help us from a regulatory standpoint because even our codes get validated by regulators. So it's like the entire audit trail of coding, implementation, and everything needs to be shared with regulators. So this was also a very important step in the migration process. So lastly, but not the least, I definitely think that we have made some bit of a progress. We've been able to overcome all these challenges and have been successfully integrated Python across all the different work streams. So we now have a new tagline, Python is our new DNA. So we thought of maybe creating three different terms for why Python. And these are the best three terms that we could come up with. The first one being, Python is extremely acknowledged. Now, this is something which is widely used by data scientists and researchers across the globe. It is available, of course, because it's quite readily available, and its most recently updated library and packages with very good documentation that even a new beginner on Python can read through and understand. The third very important point is accessibility. So it's an open source software, and it's an extremely user-friendly interfaces. So this clearly puts up Python to be way ahead of its competitors as compared to, say, other technologies. So Python has now been integrated across the different work groups at Barclays, and its 3A benefits have been leveraged through the entire model development lifecycle. Now, the model development lifecycle typically starts with the first phase, that is data understanding. This is the stage when we look at the data, we do cleansing of the data, we do data gathering, we do variable imputation, and so on, missing value transformation, all the different steps that is typically required to bring data to a shape and form that can then be utilized for the model development. Now, the second phase is the feature engineering, wherein we look at feature selection and also creating interaction variables which help us to predict better. Third phase is the model development phase, wherein we look at regression-based techniques like, say, linear or logistic, time series models, or even complex machine learning models. The fourth stage is actually even more interesting. So this is where the interactive visualization comes into picture. Now, the aim behind the fourth step is to create interactive dashboards which will help us understand the model outputs better. Now, let me just give an example. Now, typical example of a interactive dashboard could be that we have a set of models. I want to, say, validate the model on a very small population. What this interactive dashboard gives you the flexibility of the user to choose the segment. So, say, suppose I have this room, I want to look at the model, how well the model performs on the people sitting on the right-hand side corner. On the interactive dashboard, you choose that look at this particular data set, which is on the right-hand corner of the room. The user chooses it, and then at the back end, the data is already connected. We pull the data sources, we create all the reports, and then the user can actually see how the model performs on this particular subsegment. We can actually create different benchmarks to begin with. Say, suppose I built a new version of the model. I had some production models already in place. That is when we can do a comparison between how good the new model is comparison to the production models. And in the credit risk terms, the best benchmark is typically the bureau score. So the user here can say how good is the model on the right-hand side corner with respect to the bureau score. So this is the kind of visualization that partly we have done, but we want to now enhance it. Another example of some such visualizations that we are working on right now is like a typical underwriting model where we have different products. So I'm actually a credit card issuer company. We have different products. There are different cutoffs associated with each product. Now, what do I mean by cutoff? Cutoff is basically a score which says beyond the score, I think that the customer is very, very risky. So I would not accept him, because if I accepted him, the loss that I would have made for the customer, for the application, will be higher than the profits that I make against him. So this is what is the cutoff. So we have a credit card, we have different products, we'll have different cutoffs associated with each of these products. Now, what this interactive dashboard will help you do is that, say, suppose I choose a certain cutoff. Typically, our scores are in the range of 0 to 1. Say, suppose I choose a score at 10% versus choosing a score of 20%. I can actually drag and drop different cutoffs on the dashboard itself, and then the dashboard then links to the data at the back end, creates all the reports, and then tells us which is the most optimal score cutoff such that your profits are maximized. Now, these are the kind of interactive dashboards that we are aiming to build. In fact, this is not just for us as modelers. It's actually going to take us to the next level. It's going to really give benefits to the business owners and the business heads, where they can actually able to see where does the model perform better, where is there an opportunity for improvement, where is there that different set of strategies need to be applied, and so on. So it's actually taking the models to the next level. Now, coming back to the last stage, which is the implementation phase. With all these models and visualization and everything, the last but not the least is basically getting the models deployed into the production system such that our business owners can get maximum benefit out of it. Now, all these 5 steps, we have been successfully integrated Python into it. We typically look at Anaconda packages, and within Anaconda packages, We look at pandas for all mathematical operations. And when it comes to, say, statistical and any kind of logical operations, we typically look at NumPy. For all these modeling things, like which model to look at, linear, logistic, machine learning, etc., we look at the scikit-learn. And for all the visualization, we typically do it with the bokeh dashboard. So these are the different set of packages within Python that we extensively use in our entire model development lifecycle. Now moving on to the final section of my presentation, which is what is coming next. What is that we are aiming to achieve in the next 2 to 3 years with Python? The following core deliverables need to be achieved in the go-to end state to support business and enable deeper insights from the data. The first one is to have a very strong data and analytical environment. As I said in the beginning of presentation, Rome was not built in a day. Just imagine the amount of information that we as bank have. It's multiple products, multiple domains, multiple cards versus loans versus mortgages, and so on and so forth. And then history of data. We need to look at, like, say, last 5 years of data. So it's humongous amount of data. And then we need to actually capture all the monthly snapshots of data. Now, what are these monthly snapshots? Typically, for, like, if you have a credit card, you would get a monthly bill. These are your balances, this is your expected payments, this is your min due, and so on. So we need to store the entire data for as much as history possible. So that's a lot of data. So obviously, transforming everything into an Hadoop setup is not going to be an easy task. We are doing it in a phased manner. We're targeting the primary markets first, wherein we're bringing all the data for these markets into a Hadoop platform. And this is where we're going to integrate all the internal as well as external data. And this platform is where our Anaconda packages are also going to reside. So this one single setup is going to be like the to-go solution. We will have the analytical and data environment. At the same time, we will also have the analytical environment. We have Anaconda, so we can actually do all the data processing there, and we can actually get all the results from there. Now, the third but a very important benefit of integrating everything together is, again, from the regulatory standpoint, where we can actually maintain the entire internal libraries of notebooks to support not just trainings but also audit requirements from the regulators. A very important thing when it comes to a financial domain. The second part is the model execution framework. This is also where we started using Python, and we have developed a Python-based engine for model execution to be able to implement the entire suite of risk models. And not to forget, I just wanted to give you a flavor of how complex a risk model would look like. We have two different sets of models, something like, say, regulatory model and something like a decision models, typically the business models. Now, the regulatory models can be of different types, say capital or Basel models, scorecard models, or IFRS 9 models. Those are extremely complex. Like, we have a super network of feeder models feeding into them, and then something else feeding into it, and then finally creating the outputs. So these are truly very complex set of models. Coming to the decision models, we have some complexity, but obviously not to the level of regulatory models. So this model execution framework is going to be one-stop solution for implementation of all the models, all risk-related models. Now, this setup is going to be very strongly supported by controls, and as well as have the ability to produce business reports. Controls, as I said, regulators, and everything. The third point is about sensitivity and what-if analysis. So what we aim to do is to develop front-end dashboards through applications such as bokeh. I gave an example of a bokeh application. We're working towards integrating bokeh into almost all possible risk models that we have in place today. We are also trying to create automated tools to understand sensitivity, which is, say, suppose I have a model. I have, like, say, 5 to 10 variables going into it. I want to test which variable is actually the most sensitive to the model. And for that variable, if I were to change it by, say, 10%, how much is the total impact on the final output? Now, just to think about it, these are very important parameters for the business leaders, like the CRO teams. So because that is when they say that what if the bureau score deteriorates by 10%? What happens to my final outputs? Is the economic capital going to change significantly? So these are very strong metrics that is typically followed by the CRO teams. And that is when our next stage of activities are planned towards. So we really want to make a sensitivity assessment tool, and we're calling it the what if tool, and that is going to help us gain deeper understanding of the model results. In fact, it's going to help us understand how the model is operating. Now, coming to the first point, I'll try to make it quick. I am seeing that I just have 5 minutes left. So, data and analytics environment, as I said, we're working towards creating a Hadoop-based holistic system, both for data as well as analytics. So, it's going to be one single system with all the data and with all the analytics built in, such that we can actually hit that system and do whatever required on the data. In terms of content, we're looking at as much history as possible. Typically, in case of regulatory models, as long history that we can actually store the data for is required. So here we're looking at more than 10 years of data. What additionally are we going to store? We're going to store all the Barclays internal variables, external bureau variables, macroeconomic variables, and so on. In terms of what data controls are we going to put in, we're going to have very strong data lineage documentation, again mandated by regulators, wherein not just models, but data is also evaluated by regulators. So we need to give to the regulators that our data is correct. So we need to have these data reconciliations run at a very frequency, and this needs to be run something like once every month to ensure that the data which is being fed into our models is correct. So that's the controls part. Now, who is going to use this server? So this data server is going to support all regulatory and the decision models within the Barclays umbrella. We're going to support a vast array of all the business projects and strategies typically undertaken by the CRO team, which is the credit risk teams. We're also targeting to have the fraud data, which is like, that's even more complex because that's when we're looking at transaction level data. And typically, we being credit card users, one credit card, we probably use it 10 times in a month. So just imagine the amount of data that it accumulates to when we're looking at 10 years of data. Now, in terms of efficiency, that's going to be one-stop solution for all core modeling and analytical projects. This is going to reduce operational risk as well, very key parameter for a business like banking. And it's going to make things easier and faster because it's like a one-stop solution for all data and analytics environment. Moving on to the next section, which is the model execution framework. So this is where we're developing a Python-based implementation platform, which helps in quick and efficient model implementation, particularly for models which are extremely complex, like the way that I mentioned, regulatory models, which have an extensive network of feeder models feeding into it. Like we would have some 70 odd or 100 odd feeder models feeding into one single score and then creating a final economic capital. Now, for such complicated network of models, we will use what is called the model execution framework. We will have Python scripts written for data mining, model development, and data execution. So this is where we will directly interact with the earlier platform that I just mentioned, the Hadoop platform that I just mentioned. So we have the interface right here. Once the model equations are created, we will create another framework to be able to make these model equations implemented. And not just stop at this point, we will also link it to creating financial outputs as well. So we need to create automated reports and visuals such that the business team can review them and understand how the portfolios are performing. The last one is about the sensitivity and what if analysis. I mentioned a little bit about that. One such example is the bokeh application, where we created interactive dashboards, and that's going to help business gain valuable insights, not just from the data, but also from the models. So bokeh gives us the flexibility of creating a range of tools to develop numerous interactive dashboards. And we've created one sample dashboard for bokeh. I just wanted to give a quick illustration for that. So this is the example that I mentioned before, I think in the earlier presentation. So this is talking about one credit card user, one credit card portfolio. We have multiple products. We have cutoffs associated with each of the products. So this visualization is going to give the flexibility to the user, alter the cutoffs and then we can actually look at the different metrics. So in this case, we're looking at two very key metrics for underwriting, which is approval rates and bad rates. We try to maximize on the approval rates while minimizing on the bad rates. So these are the key metrics that like our CRO team typically looks at. So all this is very interactive. So this is right in front of you. You make the changes then and there, and you can understand what is the impact of the change. So this is something that we have partly done for some of our portfolios, but I think we're going to expand it for all the models that we have. The next stage is the sensitivity models. As I said, identify which variable attributes to the maximum impact on the models and how do we fix it. So that's the next stage. So I think I'm done. Any questions?